Welcome to Maths for You channel. Another past question on mathematical induction. Let's look at the question. Using the principle of mathematical induction, prove that a sum of 4r plus 1 r from 1 to n equal n times 2n plus 3. N is a positive integer. I'll start. Let me write the question again. R from 1 to n, a sum of 4r plus 1 equal n times 2n plus 1. By mathematical induction, as usual, step 1, n equal 1. If you apply n equal 1 to left hand side, 4 times 1 plus 1 equal 5. The right hand side, n equal 1, 1 times 2 times 1 plus 3 equal 5. Left hand side equal right hand side. Step 2, assume that the equation is true for n equal k. If that's so, sum of r from 1 to k, for r plus 1 equal n equal k times 2k plus 3. Just to expand it, just to see the next term, it'll be easier to see what the next term look like. So I just expanded 5, 9, 13, the last term or kth term for k plus 1. And the right hand side, of course, k plus k times 2k plus 3 that we assumed it. So that's valid. So in order to prove the k plus 1, the k plus 1 term, the left hand side is easy, as I said, it's just expanded. So it's the k plus 1 term, I'm going to add it to both sides. That is k times k plus 1 plus 1. So if I could add that term 4 times k plus 1 plus 1 to both sides of the equation, assumed equation, of course, left hand side become r from 1 to k plus 1 because of the k plus 1 term added to that. So that is r equal 1 to k plus 1, 4r plus 1. That's the left hand side. The right hand side, the assumed function k times 2k plus 3, and then a newly added function is 4 times k plus 1 plus 1. So if you could expand it, 2k squared plus 3k plus 4k plus 4 plus 1. Then add them all together or combine them all together. 2k squared plus 3k plus 4k is 7k. 4 plus 1 is 5. Let's factorize that quadratic function in k. I just did a little cross, and 2k and k is the factors of 2k squared, and then the bottom is factors of 5, which is 5 and 1, the way you write it. So if you could do that, the top, 2k times k, 2k squared, 2k times 1 plus 5 times k, 7k, that's the middle component, and 5 times 1 is the last one. So the factors are k plus 1 and 2k plus 5. So if you could write the right hand side, so k plus 1, and I just separate that to make it k plus 1. So 2k plus 5, I wrote it as 2 times k plus 1, that is 2k plus 2, then 3 left. 5 minus 2 is 3, or 3. So this is equivalent to the n equal k plus 1. So therefore the equation is true for n equal k plus 1. Then you can say that is all that function, so that the actual function r equal 1 to n for r plus 1, for r plus 1 times n time 2n plus 3, isn't it? 2n plus 3. Thank you. Please subscribe the channel and select auto notification. Thank you.